Hello, welcome to our Python programming course CS205. I am Wiseborn. For today, we're going to look at decision and control structures in Python. But before we do that, let's take a recap of the topics we saw last week. Last week, we saw variables. We explained that variables are just references in memory of the computer where we store and retrieve data. We also saw the different data types in Python, the numeric and text data type, where for numeric, we examined the int, float, and complex data types. Text data types, the string was also looked at. The different operations that could be performed on the string data types were also looked at. How to write statements and expressions, and also evaluate them in Python, looked at in detail. For today, let's look at decision and control structure. Let's recall that in our first lecture, we explained computer programs as the steps of instructions that the computer follows to perform a task. Now, these steps of instructions have a flow of logic. They can either be sequential or selective or repetitive. And these define control of a program. So there are three ways in which these steps of instructions could be executed. They could be sequential, where the steps will be followed in sequence from step 1 to step 2 to step 3, or selective in nature. We can run step 1 and then jump to step 3, jump to step 4, jump to step 5, or jump to step 10. Or we could have a repetition of the steps. We could repeat step 1 to 4, go to step 6, and then repeat 1 to 4 again. So these are the three main flow of logic or flow of control through a program. Now we're going to use these three types to help us write good programs in Python. Let's use the flowchart to demonstrate this flow of logic in a program. So for our example, we're going to take a program that is used to compute the wages or remember that you need two basic data to compute the wages of employees, the hours worked and the hourly rate. So the first two steps in our program would be input the hours worked and then input the hourly rate. These steps will be done sequentially. Then the next stage is that we need to make a decision. How will we compute the wage of the employee? If the hours worked is more than 40, then we need to compute the wage of the employee with the overtime rate. If it is not more than 40, then we need to compute the wage without the overtime rate. So here, we're going to make a decision as to which step to follow. Compute the wage with overtime rate or compute the wage without overtime rate. So this is a selective flow of logic. Then we get to the next stage where in the company, they have to make sure that every employee earns more than the minimum monthly wage. In that case, the computed wage will be compared to the minimum wage. If it is less than that, we add 5% bonus. If it is more than that, then we just output or print out the salary of the employee. So the case whereby the employee's salary would be less than the minimum wage, even after adding 5% bonus, would continuously be executed over and over again till this condition is satisfied. Here, we're going to loop through this process so many times till the condition is satisfied, then we leave the loop. So we have the repetition, we have the selection, and the sequential. Note that this flow of logic is not just restricted to Python programming language, but all programming languages. Now, remember that we said over here, we would make a decision, and based on the decision, we select either the step of computing the wage with overtime or computing without the overtime. So then it means that in order to make the decision, we need to have an operation. These decisions are made based on a condition. And these conditions are evaluated to be either true or false, yes or no. These type of data or values we get from expressions are known as Boolean values. Yes or no, true or false. So how will we compute or perform conditions that are of Boolean values? We have different relational operators. These tells us the relation between two conditions. So if condition 1 is equal to condition 2, or condition 1 is not equal to condition 2, or condition A is not equal to condition B, condition A is less than condition B, condition A is less than or equal to condition B, or any of these conditions, A is greater than or equal to condition B. And these conditions evaluate to either true or false. So this helps us to make decisions in our control flow because they evaluate to true or false. Now we also have the Boolean operators that helps us to combine one or two conditions. So in the decision making, instead of checking whether the minimum wage is more than or equal to the wage of the employee, we could have different conditions combined together. For example, if the employee is a full-time employee, his wage is less than the minimum wage. Now, these operators help us to combine two or more conditions as well. So we have the AND or and not. The AND operator functions this way. When you have conditions that are to be satisfied or to be evaluated, all the conditions need to be evaluated to true in order to have a true result. If even one of them is false, the results will be false. So as you can see from the table, true condition and a true condition gives us true, true condition and a false condition gives a result of false, false and true condition gives us a result of false. Or false and false also gives us a result of false. We can also combine two conditions using the OR operator. These operators are Boolean, as I have explained earlier on, so their results are either true or false. Now, the OR works this way. When you combine multiple conditions, either one of them needs to be true in order to have a true as a result, or in order to have the result as true. So you have a true condition with a true condition, the results becomes true. A true condition and a false condition, the result will become true. A false condition and a true condition, the result once again becomes true. And definitely, a false condition and a false condition combined gives us a result of false. These conditions could be more than two. We could have 4 conditions, X or Y or Z. Then in all these instances, the operations applies. We also have the NOT operator. The NOT Boolean operator is just the negation of the condition. So for example, if this condition is not met, then the other holds. So if not true, then it's false. If not false, then it's true. So now we've seen the flow of logic within a program, the different types, sequential, selection, and repetition. We've also seen the relational expressions or relational operators and Boolean operators that will help us to combine multiple conditions. Let's look at the tools or statements in Python or programming that will help us implement these control flows. The simple if is the first decision control structure we would look at. The syntax is if the conditions you are going to evaluate and the statement that will be executed if the condition is met. Now, the syntax of a programming language is basically the rules that governs the language. So this is the rules of using the if decision statement. First, you need to have the if keyword, the condition, which is a Boolean expression, or which should always be a Boolean expression. That is, it should evaluate to a true or false, and the statement that should be executed if the condition is true or if the condition is met. Now let's look at an example. Here, let's look at this statement line after line. So in the first statement, we're getting an input from the user using the input keyword. The input keyword in Python enables the user to enter any input he wants. you can put the prompt in a string format, that is in double quotations or a single quotation. Now, note that every data entered at the keyboard is of type string, and therefore, to perform a mathematical operation, we need to convert it into a data type that will help us to perform mathematical operation. In this instance, we converted it into the int type. Remember, conversion of one data type to the other, we use the float, int, or str functions, and then the parameter or the input data is the value we want to convert. So the value entered by the user at the keyboard, which is a string, is then casted or cast into an integer type and assigned to y. Y modulus 2 equals 0, then the value is even, so we print that to the user. If this condition is not met, that's if the condition is false, then we print outside the box. So it means that we are leaving the if block. Now, this is a simple if statement. What if we have so many conditions that are to be met before some instructions or some steps are executed? In this case, we have what we call the sequential ifs. In the sequential ifs, this is the syntax. You have if the condition, the statement that are to be executed if the condition is met. Then you take the next if and the condition statement that are to be executed in that order. You can take as many as you want, but we will look at the disadvantages of using the sequential ifs and what we can do to make your program look better. Now, do not forget that in Python programming language, we have blocks of code. Every block of code should be indented, and then the beginning of every block of code is shown by using the colon symbol, as you can see here. So let's see an example of a program that uses sequential ifs. In our program, we will take the data from the user and determine whether the number is positive or negative. So just like I've explained in the first step, we get an input from the user from the keyboard, which is a string, cast it into an int type, and assign to y. If the value assigned to variable y is greater than 0, then we perform this statement, meaning the condition is met, y is positive. If it's less than 0, then this condition is met and y is negative. If it is equal to 0, then we get this statement. So this tells us that we can have as many as possible if statements, and all of them will be executed line after line. Now you realize that these statements are executed line after line. If the conditions are not met, we don't do anything. But sometimes you have a program that gives you the opportunity to do a different task if the conditions are not met or if the conditions are false. Just like our example we saw, if the employee worked less than 40 hours, the wage is to be computed with the normal hourly rate. But if the time worked is more than 40 hours, then the wage will be computed with the overtime hourly rate. So if the condition is met, a different statement is executed. If the condition is not met, a different statement is executed. In that case, we use the if-else structure. So the first statement will be executed if the condition is met, and then if the condition is not met, we get the next statement. This tells us that this structure is to be used when we have conditions that are mutually exclusive. Only one would be true at a time. Let's look at an example. So note that every number could be either an even number or an odd number. So then it qualifies for us to use the if-else structure. So we take the input from the user and then take the modulus 2 of the number. If it is equal to 0, then the number is even, else the number is odd. So this gives us the opportunity to go through different steps of the program, select which one to execute. Now we've seen the if-else. Let's compare the if-else to the sequential ifs. Note here that we have different steps that will be performed. If the number is even, then we print the statement. We go to the next one, we go to the next one, like that. So that tells you that we use the if statement if all the conditions may be met. Now we saw that if we use the sequential ifs, all the statements in the if condition will be executed. That will slow our system. Imagine we have thousands of if statements. We will go through all of them to execute. But sometimes we have a program that we would want to consider only one condition being true. If one condition is true, we don't need to go through all the other statements and take the time of the processor or interpreter doing that. So we have what we call the if-elif structure. Now the if-elif structure executes just the first block whose condition evaluates to true. All other blocks are ignored. Then we leave the if clause or the if statement. So we have the syntax as this: if the first statement, if it is not true, we go to the elif. If that is not true, we go here. But if the first elif statement or condition is true, then we don't go through all the other elifs. Let's take an example. So here we're getting the input from the user, and then we check, is the value of the user modulus 2 equals to 0? If yes, we print even and leave the if clause and go to the next statement. On the other hand, if the value is not equal to 0, then we check the next condition. Is it not equal to 0? If it is true, then we go to the next statement. Note that, for example, if the user inputs a number like 2, yes, 2 is even, so that will be printed 2 is even. Even though this condition is true, y, which is 2, is greater than 1, y is greater than 1 will not be printed because it only executes the first condition that evaluates to true. All the others are ignored. Let's do a quick comparison between the if-elif and the sequential if. The sequential if goes through all of the if statements. So this will be executed, this will be executed, this will be executed. So for example, if the user enters 2 modulus 2 equals to 0, yes, 2 is an even number, will be printed, and then this would also be printed because the condition is met. 2 is greater than 1. After that, we go outside the print, outside the box. But if we use the if-elif to run this program, as soon as we get to this statement being satisfied, 2 modulus 2 equals to 0, we leave and go to print outside the box without outputting y is greater than 1. Now, sometimes you have a condition or you want to specify what should be done after we leave the if-elif statement and none of them or none of the condition was true. In that case, you can use the else statement to execute that condition or that statement. So if the first one is not met, the elif is not met, all the elifs are not met, then you go to the else to execute that. Let's now look at the repetition control structures. To assist in our explanation, let's go back to our flowchart. In our flowchart, we could see that we have some operations that are carried out or initial operations that are carried out in A. The sections of the flowchart are not shown, but you could refer to the other slides. Then we have a condition. If the condition is not met, we perform an operation that changes the initial condition or the initialization statement. Then we go back to test the condition again. If the condition is not met, then we perform more operations to change the status of the initial condition we set. Come back, check the condition again if it's not met. So we go through this loop over and over again till the condition is met, then we exit the loop. So let's take an example. If the wage of the employee is computed as 20 and the minimum wage is 5, we would go through this process, adding bonus over and over again till we get a number that is equal or greater than the minimum wage. Then we exit the program. So looking at the flowchart, the three key things we saw or we need to loop or iterate over the statement is the initialization point. That is what happens before we enter into the condition. The condition that if it's not met or if it's met, we can loop through. Then we have an operation that is carried out to give us the stepwise order in which the looping or iteration is supposed to be done. Now, after looking at these three key items, Let's look at the types of repetition structures we have. We have the closed-ended and the open-ended. In the closed-ended, the number of iterations we need to undertake is known before the start of the iteration. For example, if you are writing a program to count the number of even numbers between 0 and 10, we know beforehand the number of even numbers that exist there. Or if you are printing the number of students in a class, names of students in a class, we know the names of students in the class before the loop. The open-ended loops, we do not know the number of iterations that is required. For example, in determining the number of times you need to toss a dice to get 6 as an outcome, we do not know beforehand the number of times you would have to carry out the experiment or the operation. So such kind of loops, we have to use the while loop. So when you know the number of times you have to perform an operation, you can go for the for loop. But when you don't know the number of times you perform an operation, you can go for the while loop. Now let's look at the structure of the for loop. So for the for loop, we have the initialization statement, the conditions, and the step operation. And this is generally true across most all programming languages. In Python, to make it easier for us, both the initialization and the step operation have been catered for by using what we call iterator objects. Iterator objects are basically sequence or object that defines sequence of a type. So they have an initial point, they have the next value, and they have an inbuilt increment operation. The inbuilt increment operation helps us to move along the loop. Examples of iterator objects are the list, dictionary, tuple, strings, and sets. We've not seen all of them, but we saw string in our previous lesson, so we can use string in our program. Now let's take an example. So in this instance, we're using the string yspawn, and then we're going to take each character of the string and loop or print it out. So we assign a variable by name character, and then keep on storing each element of the string into the character variable, and then printing the element out the number of times we have the elements in the string. So the looping will take place how many times? 1, 2, 3, 4, 5, 6, 7, 8, based on the number of characters in the string. One function that aids us in Python to perform a repetition operation is a range function. We've not seen functions yet, but the only thing we need to know to understand this is that the range function outputs a sequence of numbers between 0 and n-1. So if you put range 5, you're going to get numbers from 0 to 4. So the range also have a different format that you could use. Range, the starting point, the end, and the step. In the first range, you just put the end over there. The start and the step are optional. So if you leave the start out, the default starting point is 0 and the default step is 1. So what are the starting point and what are the steps? The starting point is where we start from, and the step is the incrementing factor. So you start from 0, increase it by 1, 2, 3 in that order, so you get to the number before the end. That's n-1. Now let's look at the while loop. In the while loop, because we don't know the number of iterations you carry out, we always test the condition to make sure that the condition is met before we do the operations. We also need to terminate the operation. If you do not terminate the loop operation for all loops, you're going to get an indefinite loop. That will mean that the statement will run over and over again. Let's take an example. So for example, we're getting an empty string as a command. Then we check if the user enters quit, then the program would quit. So if this condition is not met, that's if the command is not equal to quit, then we'll run the program till the user enters QUIT to quit. So that's an example of the while loop. We don't know the number of times the user would continuously play the game. So we give the opportunity to the user to enter as many times as he wants till he wants to end, then he enters quit. We can also have an example of the while loop here, where we want to print numbers from 0 to 5, the maximum number as 5. So in that case, we continuously increase the counter till this condition is satisfied. Then we exit the loop. Let's look at some keywords that are associated with the loop. We have the pass statement. With the pass statement, it works like this. Whenever you have the if-else condition, for example, and you do not provide any statements for the else, you're going to get an error. In order not to get an error, you need to put the pass keyword to show that this would not be implemented. So the pass keyword helps us to avoid getting errors in our program if we leave a component of the if-else or if-elif statement out. We can also use the pass statement in functions, classes as well. We will look at them when we get to functions and classes. Now we also have the continue statement. So let's take an example. For example, let's say we want to print the numbers from 0 to 4. Once again, using the range function. This is going to print for us 0, 1, 2, 3, 4. So for example, here, if the index is an even number, then we skip it. So it's going to print for us 1 and 3. We start from, it's going to skip 0, then we get 1, skip 2, get to 3, and skip 4. So whenever we get this condition to be true, we continue to the next. The continual statement skips the current iteration and starts the new one. For example, if you have a range of numbers from 0 to 4, by using the continuous statement, when this condition is true, then it means that we're going to skip to the next iteration. So when we take 0, is 0 modulus 2 equals to 0? Yes. So we skip that iteration and go to the next one, which is 1. Is this condition met? No. So we print 1. Then the next iteration will be 2. Is 2 modulus 2 equals to 0? Yes. So we skip that and continue to the next iteration. This continues till you get to instances where the condition is not true. So that is how we use the continuous statement. It skips the current iteration and moves to the next one. The break statement also terminates a loop or an iteration regardless of the results of the test. So for example, this one prints from 0 to 4, as you can see here. Now when we get here, if this condition is true, then we break the loop, no matter the iteration we are on, or whether we finished or not finished with all the elements in the sequence. So here, if the condition is 3, then we terminate the iteration or the loop. This brings us to the end of our lesson. In this lesson, we've seen different control and decision structures in programming. We focus on the syntax of the if, sequential if, if-elif, and the if-else statements. We also looked at for loops and while loops, seeing the structures of them, and looked at some examples. In the lab sessions or in the practical assignments, we will take more examples to perfect our understanding on these concepts. Thank you and see you in our next lesson. Bye-bye.